page 277. So the next little bit is all about graphing quadratic functions. Okay. We're used to seeing quadratics written this way. Okay, I know that doesn't look like something we've done, but that's the same as writing it like y is equal to x squared plus 2x plus 3. Okay, just expand it out like that. That's how we're used to seeing it. All right. That is called the general form. Okay. There's also standard form, which we're going to see, and that's what we're going to work with at the beginning here. Is the standard form, which looks like this. All right. So that would look something like y is equal to 2x minus, I don't know, 3 squared plus 4. All right. And then these numbers tell you things about the graph. That's why we like standard form, because it tells you where the graph is. Okay. We will learn how to go back and forth between these, how to convert them. But if you're given a graph or asking you to sketch a graph, standard form is the better way. I shouldn't say it's better. It just gives you more information. Okay. So the first graph we're going to look at is y is equal to x squared. So on the next page. Now, we're going to kind of change up how we do this. I'm going to use Desmos here. If I enter x squared, whoa, yeah, x squared. There's the graph of x squared. Okay. It's a parabola. It's centered at the origin. All right, the origin is 0, 0. There you go. Okay. Opens up. No big deal. So if I asked you, what is the domain? If you remember what domain is. It's the definition of domain. Sorry? Domain is all the possible x values. Okay? So if we're looking at our notes here, we know that this graph, we'll draw it here, of y is equal to x squared. We're not doing that table of values. Looks like this. That's a bad looking parabola, but we all get the idea. Opens up. Okay, that's what I just had on Desmos. The domain of the graph, i.e. what I'm asking you is, are there any x values that are not allowed on this graph? Look at the function. It's x squared. When is the only time you have x values that are not allowed, or NPV? When it's a fraction. When you have variables or x's in the denominator, right? Do we have that? No. So it can be any number we want. So if you remember grade 10, they would say all real numbers, but it's written like x. It's not an e, but everybody, I call it an e. So this means x is in the set of r real numbers. X can be anything is what it means. Okay? The other way to write it, that you'll see when you go up into the higher levels of math, but you don't have to do it right now, but I'll just show you, is negative infinity to positive infinity. It can be any number between negative infinity and positive infinity. That's what it's saying. Okay, it can be anything. So all parabolas, and that's what this shape is, called the parabola, that shape, have a domain of XER, or all real numbers. Okay, because there's no variable in the denominator. What is the range of this graph? What are the possible y values? Can you have negative y values? No, because it starts at 0 and it goes up. So we would just say the range is y is greater than 0, or equal to, sorry. Can be 0. Greater than or equal to, that's what the little line underneath means. Okay. If you're doing it in the other notation for that, you would write square bracket 0 to infinity with a rounded bracket. The square bracket, and I will talk more about this in grade 12, means it includes a number. That's the or equal to part. The round bracket means it does not include the number. And we always have round brackets on infinity because you can never get to infinity because infinity is not a number. Okay, it's an idea, but that's way beyond the scope of this course. Okay. So if you have an x squared graph, it's a parabola opening up. Some terminology. The vertex is this point. It's like the lowest point if it's opening up, or the highest point if it's opening down. It's like the point, essentially. Okay. The axis of symmetry is basically, how do you split the graph in half? Okay. So in this graph, the axis of symmetry is right down the middle here. That splits the graph into two equal parts. Okay. And the axis of symmetry always has the equation x equals, and whatever the vertex point is, in this case it's 0. Okay, but we're going to talk about that in a bit. Okay, so the domain of all parabolas is all real numbers. X here. The range will change. This one is greater than 0, but that can change. The vertex is the, like, when you're drawing it, it's the point at the bottom, or if it's opening up or opening down, it's the point at the top. We'll see that. And the axis of symmetry is the line that splits the graph in half. Okay? All right. We said on the previous page that this was standard form. It's got these P's and Q's. All right, we're going to deal with A later. We're going to look at what the P and Q does right now. Okay? So let's go to page 279. But I want to just look at Desmos for a sec here. So here's my graph, x squared. If I add in, I go plus 3. What did it do? It moved the graph up 3 units. 1, 2, 3. That point there is now 0 and 3. Okay? If I change it to plus 5, what's it going to do? It's going to go up 5. If I change it to minus 3, it moves down 3. If I change it to minus, I don't know, 0.5, it moves down 0.5. Okay? That makes sense? You can see it. It's moving it up and down. All right? That, and you can see it's x squared minus 0.5 or x squared minus 2 or plus 2. That is your Q value. That thing right there. The Q value moves the graph up and it moves the graph down. Okay? I'm going to summarize this. You don't have to write it down yet. Okay? If we look at, now we're going to put a number inside the square. Okay? This is called the P value. So if I take the same graph, there's our x squared. So now, bracket, whoops. X minus 2, bracket squared. Whoops. Yeah. And I'll put up the regular graph, x squared. There it is. What happened when I put a 2 in? Here, x squared is the blue one. There's our 1 right at the origin. I put a 2 in there. What did the graph do? Move the vertex 2 units to the right. That is at the point 0, 2, 0 now. Okay. Remember, it's always x, y. What if I do x plus 2? Where's it going to go? The other way. To the left. Okay. Because if you're solving this, if I have this, and I say, what are my x-intercepts? Okay. X-intercepts make the graph, make y 0, right? So if I put equals 0, and I solve this, you square root both sides, correct? So if I square root that, I get x plus 2. What's the square root of 0? 0. Move the 2 over. What does x equal? -2. That point right there. Okay. The tricky part about the p value is when it says x minus 2, which way does it go? It goes to the right. When it says x plus 2, which way does it go? It goes to the left. All you have to do is just ask yourself, what makes it 0 in here? 2 makes it 0, so it moves 2 units to the right. What makes this 0? Negative 2, so it moves 2 units to the left. Is that okay? So P, we will summarize this. So I'll just write on the board for now because I want to do something else. So we have the equation y is equal to, we have this. P equals left, right, Q equals up, down. And they're not called left, right, up, down. They have special names, but we'll talk about that in a second. But I don't care if you say left, right, up, down. It means the same thing. Okay, now, what if if I put in a p-value, right, of 2, moves it 2 units to the left. What if I had a q-value? 4. So now it moved it up 4 units. So it moved the graph, it moved this blue graph, which is the x squared. The 2 moves it 2 units to the right, 1, 2. The 4, which is the q, moved it 1, 2, 3, 4 units up. And that's where the graph goes. What do you call this point? The vertex. So if this is the vertex, it has the values 2 and 4. The 2 is what? Which one of these? What letter? That's the P. What's the 4? So what are the coordinates of the vertex? P and Q. Okay? So if I give you an equation, if I write this, and said, what's the vertex? 3. Negative 2 is the y value, the q. It's negative 1 though, right? Because this, it's, if I wrote that on the graph, if I did this, it goes to the left, right? What did it say, minus 2? There's right there. So there's your vertex. Okay? So if you get the equation, you know where the vertex is. It's your P and your Q value. And the P, the only trick with the P value is it's opposite of what you think it is. Okay? The Q value is whatever that number is. Okay? Okay? All right. Let's take this equation right here. If I asked you to split that graph in half, let's get rid of this. Draw a line that splits this graph in half. Where's it going to go? Negative 1. It's going to go right through the vertex, right? What's the x value of the vertex? Negative 1, right? We've shifted it over. So it's x equals negative 1. So when I ask for the mirror line, and again, I'm going to summarize this. It's always x equals whatever your p value is. Okay? And that was like a full lesson in like 10 minutes. Okay? We're going to summarize it right now. All right. So let's go to this page right here. 281, please. And we're going to go right to this stuff right here. Here is our general equation. Y is equal to x minus p all squared plus q. Okay. All right. First one. P or Q value in there. That's a P value, right? Because it's inside the brackets with the X. So, what is my P value? If I said, what is P? You would tell me it's negative 10. Thank you. What does that mean if it's negative? Which way do you go, left or right? You go left. Right? Okay. Is there a Q value? No. Well, you could say it's 0, but nobody would say that, right? So Q is 0, so we don't worry about that. Okay. B. So all we're saying is, which way did we go? What's the P or the Q, and which way did we go? Y is equal to x squared plus 4. P or Q? Q, because it's outside. And Q is just whatever the number is. Did we go up or down? So we went up 4 units. So I guess let's just sketch these graphs just because we're here. This graph would be at negative 10 and look like that. B, we moved it up 4. Whoops. Well, helps if you actually go through the point. There we go. And so I just moved it 4 units up. All right, C. What's wrong with the way C is written right now? Q is on the wrong side. It has to look like this. Y equals long. Okay? If Y has something on that side, get rid of it. How do I get rid of the 8? Subtract it over. When you subtract it over, it does not combine with this. Those brackets are like walls. They protect it, okay? You cannot combine it. So you would just write x minus 5 all squared minus 8. Now, what is my P and Q? What's P? Sorry? Positive 5, which means we went which way? Right. And Q is negative 8, which means we went down. What's my vertex? What? 5 and negative 8, right? P and Q. So if you're going to sketch this graph, you went 5 right, 8 down. Just guess where 8 is. That's your vertex. It opens up. Right now, they all open up. We'll deal with the ones that open down in a bit. And that's it. What's the mirror line or the axis of symmetry? Yeah, axis of sim. It's x is equal to 5. It's the line, if you drew it, splits the graph in half. Is that okay? All right. So, obviously, mathematicians, being mathematicians, don't say left, right, up, down. They have to have fancy names. Okay? You can say left, right, up, down. I'm fine with that. But you're going to see these words, so you need to be familiar with them. If you're going left and right, you are going horizontally. Okay? So that is called a horizontal translation. Okay? The key word here is horizontal. It means you're going left, right. Okay? So as soon as you see the word horizontal, you know it is a P or Q. That is a P value. If you're going up, down, it is a Q, but what would you say? Vertical, thank you. All right, so horizontal translation of 5 units right. So my P value is what? 5. Okay. Now they want us to, if I don't say anything about going up or down, what's the Q? It's just 0. So they want us now to translate these words into one of these equations. Okay? The general equation that I will write on the board, you don't need to memorize it, but we're going to use it so often, is this. They just told us we did a horizontal translation, 5 right. So you told me my p-value was 5, and the p-value was 0. Just plug them in. So I get y is equal to x minus 5 all squared. Okay, what if I say you go 6 units down and 4 units left? So translation, 6 units down. What number is that, P or Q? That is your Q. And what is the Q value if you're going down? Negative, so Q is negative 6. 4 units left. Sorry? This is the trick. Your P value is negative 4, okay? But when you put it into this equation here, you're going to get x minus your p-value, which is negative 4, and then the q's on the outside. What doesn't 2 negatives make? So that's why it looks like positive 4. So if I ask for the p-value, or I tell you the p that you've gone left, your p-value is negative 4, but when you put it into the equation, it switches this to be positive. That's the trick. Okay? Is that okay? P is left, right. Q is up, down. Horizontal translation is the P. Q is called a vertical translation. I would like you to do numero 1. Just number 1, please. So, this is a standard type of question you're going to see. Write the coordinates of the image. So I'll read it out in the math speak, and then we'll translate it into actual proper normal people English. Write the coordinates of the image of the point 39 on the graph y is equal to x squared when its translation of 2 units up and 7 units right is applied. So it's saying you start with this point. This is your starting point. You do this. Where are you? Whoops. Where did the point move to? Okay. So remember that when you're writing an ordered pair for a graph, it's always x, y. So that's x, that's y. That's where you start, your x and y points. If I say we do a translation 2 units up, is that P or Q? Q. And if we went up, it's plus 2, right? We went 7 units right. That is P. Is it positive or negative? Positive. 7 units right, it's positive. All right, it'll look like this in the equation, x minus 7 all squared, but the p-value is 7, okay? Okay. Does p affect x or y? Sorry? Does the p-value affect the x or the y value? X, because you're going left or right. And the q only affects the y value because you're going up or down, okay? So there's 2 ways to do this. One is you could literally mark the point 3, 9, just guesstimate where it is. 3, let's say 9. That's nice. So 3, 9, that's our starting point. And then we do 2 units up and 7 units right. So we go 1, 2 up, means we're now at 11. And then we go 7 right. 1, 2, 3, 4, 5, 6, 7. So where did I finish? So my coordinates are 10 and 11. You can do it that way if you want. Like literally just mark it and then just mark it out on a graph. Or if you're more of a mathematical person, and I'll give you these equations. The new point, the x value, the x coordinate will be p plus, I'll say x1, which is the original, and the y value is q plus y1. So if you think of it that way, our p value is 7 plus the 3 gives you 10, and our q value was 2 plus the y value, which is 9, gives me the 11. So I get 10 and 11. Okay? It depends on how you think of it. All right? I don't care which method you use. If you want to do the graphing, if that makes more sense to you, that's fine. But we're going to start to add another layer to this. This is preferable, but the graphing will always work. Okay? 4 and 10, please.